I'm going to show you something today that, in my opinion, is probably one of the most critical issues having to do with grow lighting. It is thermal management. My name is Rick Nathans. I'm one of two principals of SpecGrade LED. My competitors all think they're in the lighting business, when in fact we're really in the electronics business. The electronics just happen to light up. And in the electronics business, if you don't get rid of the heat, you'll destroy the electronics. Your grow lights, in other words, are going to become landfill. And it's not only getting rid of the heat, but the speed at which you get rid of the heat. The speed is a function of the heat transference, the materials that are being used within the grow, in this case, within the grow light itself. Now, there's a whole science around thermal management, and that's really beyond the scope of this video. So let me try and explain it to you how our engineers explained it to me. There's a formula out there having to do with thermals and the life of the electronics, and it's called the Arrhenius Equation. The Arrhenius Equation is really simple in that it basically says as the heat goes up, the life goes down. As the temperature increases, the life of in this particular case, the life of the LED diminishes. And it's not really a critical problem until the heat gets to be somewhere between 110 to 120 degrees. As a matter of fact, the failure rate increases exponentially as the temperatures, for every 10 degrees Celsius of increase in temperature. Now, there's two common ways to pull the heat off of the LED substrate. One is active cooling and the other one's passive cooling. The active cooling is simply a fan, fans that are built into the LED fixture themselves. It's very common, but it's very poor engineering because it's one more point of failure. If that fan goes down, if it stops working, your LED grow light's garbage. Passive cooling is much better. It's a little more expensive, but it's better. Generally, in our world of grow lights, aluminum gets commonly used. Now, with aluminum, the way it works is the more surface area you have in the aluminum, the more able the heat is to come off of the LED and come off quicker. That's why aluminum heat sinks have fins to them, because it creates much more surface area. To show you my point, what I have here is some commonly used heat sinking methods in the industry. This is one of them. This is commonly gets used in the industry, this grow light bar. What I did was I took a section of it and to illustrate to you how it's constructed. And both of these, by the way, put out the same amount of electricity. They're both generating about 645 watts. And as most of you know, a watt is a watt, a BTU is a BTU, so they're both going to generate the same amount of heat. It's simply a question of where does the heat go. And as you can see, both bars are aluminum, which is terrific. But you can see on there the amount of surface area that this particular style has. And this is our Verta 8 from SpecGrade LED. You can see all these fins indicate the amount of surface area that we have. Now, on a Verta 8, we have almost 5,000 square inches of heat sinking. On the comparable fixture that's commonly used in the industry that uses this particular method, it runs between 800 and 900 square inches of heat sinking. So what happens is when the heat's got to go somewhere, so it's going to radiate out of the LEDs and down onto the plants. There's very little surface area up here for it to be absorbed into. Consequently, the heat ends up going on down to the plant. Whereas with the Verta 8 bar, with all of the surface area, On this method that SpecGrade uses, the heat off of the LEDs gets absorbed into the fins and the heat comes off the top, making your plants a lot happier by not getting showered with all that radiant heat. This is less expensive methodology to use than this is. But you'll also notice in terms of the LEDs are spread out over a 3-inch surface rather than 1-inch wide surface on this type of grow light bar configuration. The takeaway is to do your due diligence when you're looking at an LED grow light. Not all LED grow lights are created equal. Take an extra hard look at the thermal management. It's extremely easy to do. Just have your representative, your salesperson, fire up both of them and feel the heat with your hand. Don't put them too closely on. Many of the brands will take your fingerprints right off. If it takes your fingerprints off when you touch it, I suggest you not buy it. If, however, you can touch it, feel the heat coming off of it to be very minimal, then that's something I suggest you consider. But if you're in this industry for the foreseeable future, I strongly recommend that you get a better quality grow light, which means a better quality heat sink.